In this video, we're going to talk about 9.2 Objective 3, where we find and interpret standard scores and critical values for a hypothesis test. We're going to be using technology for a lot of these things to conduct hypothesis tests. Let's go ahead and get started. I'm using the TI-84, and I'm going to hit my stat key and arrow over to tests. And we're going to be conducting a z-test here for the mean, which is option 1. We have our stats to put into the calculator. Our claim for the mean is 6.50 grams. Our standard deviation here is 3.00 grams. Our X bar for our sample was 5.50 grams. The number of pieces of data sampled was 49. And our HA is a less than statement, less than our value that is claimed. So HA is less than 6.5 is what we're saying there. Don't worry about the color. I just like blue and leave it on that. So our Z-score right here is negative 2.33. And the critical value for a 0.05, let me just show you what that is. We're going to show you that one time. Second distribution, inverse normal. I want 5% to be to the right, because this is a greater than, 5% to be to the left. And that is going to be critical Z value is negative 1.645 for a one-tailed left. Alpha equals 0.05, right? So let's take a look at what that means here. That here's our negative 1.645 critical Z value that causes a rejection region over here to the left in the direction of HA. And then I found a test statistic of negative 2.33, which is somewhere right around there, which is in my rejection region. We want negative 1.645. They told us to round to 2 decimal places, so negative 1.65. The standard score is more extreme than the critical value. So we're going to reject H naught. The alternative hypothesis is supported. So our decision here is we reject H naught if our Z value is less than or equal to our critical Z value. All right, let's keep going here. Find the hypothesis, find the value of the standard score Z and determine whether to reject the null hypothesis at the 0.05 level of significance. Is the alternative hypothesis supported? I do want to go back and show you something here, actually, with this test here that we did, because I didn't talk about the p-value that comes up here. I know we're not talking about making a decision with p-value right here, but we already talked about it in an earlier video. So because this p-value here is less than my alpha of 0.05, I know immediately that I'm going to reject my null hypothesis and that there's enough evidence to support my alternative hypothesis. And that's what I was saying, how easy it is to just look at this p-value number here. That's what this p is. That's this little p in my calculator is really my capital P value. So don't get that p from the hypothesis test mixed up with population proportion or something like that. It's not. It's the capital P hyphen value that we've been talking about. That's the probability of being more extreme than our test statistic. Okay. Let's go ahead and stat test number 1 again. Since n is large here, our claim here is 21.2. Our sigma is 1.5. Our x bar is 21.9. Our n is 121. And we have a greater than situation, and we have alpha is 0.5 again. And so our critical z value again should be 1.645, but they tell us to round to 2 decimal places. So the value of the standard score is 5.13, which is definitely bigger than 1.65. And look at that really small p-value of 0.0000001, right? It's practically 0. This is so extreme. And so the standard score is at least as extreme as the critical value. So we're going to reject H naught. And the alternative hypothesis is supported. Stat tests, z-test, and we're going to come in here. Mu is 18.1. Sigma is 1.2. X bar is 17.8. N is 64. And we have a two-tailed not equal to situation here. And we're going to calculate. And it already takes care of the two tails and multiplies by 2 for us to get the appropriate p-value for us to compare to alpha. So the value of our standard score is -2, and the critical value for a two-tailed 5%, it's -1.96. Positive 1.96. We've been dealing with that from the 95% confidence interval. It's the same numbers. We're just looking at the tails now, where there is 95% in here and 1.96 for the z-value and -1.96 for the z-value. Now we're looking at the other 5% that's here, where 2.5% is up here and 2.5% is down here. But it's the same cutoff regions that there's 95% in the middle. So C is 0.95, and we get 1 minus C is equal to alpha. So 0.05 is my alpha, and I need my alpha to be split up into two tails. So 0.025. We could kind of look that up on reverse look up that on the z table if we wanted to, and we'd see that to the left of -1.96 there's about 0.0250 on the z table, and then that would mean that there's that much above 1.96 as well. -2 is more extreme than -1.96. -2 is there, so we are in this rejection region down here. So the standard score is at least as extreme as the critical value or values. So we're going to reject H naught, and the alternative hypothesis is supported. Use the hypothesis testing procedure flowchart interactive to answer the following question. We're not going to watch that. You can, but we should be able to answer this question here without watching. In conducting a hypothesis test, the critical value is z equals -1.96, and the test statistic is -1.00. Which of the following is the correct decision? We fail to reject H naught because we are not in the rejection region. We'll draw a picture. Here's -1.96. I would need values that are less than that, more extreme than that. And we had a z value of -1.00, which is not in this rejection region. Okay, that's it for this video. We'll come back next time and we will talk about 9.2 Objective 4. See you for the next video.